Hey guys, I'm looking at some more area problems, and I was looking at some really cool painted basketball courts, and I thought this is a perfect opportunity to kind of apply what we've been doing with composite areas, and finding cost for things. Now, I'm not going to get really crazy. If you look at some of these basketball courts, um, they get insane. But I was gonna look at this one right here, where we notice the 3 point area is yellow, the circles are red, and then everything else is blue. So you're gonna get an assignment in the Google Classroom about painting a basketball court and finding how much paint you would need in order to do that. So that's what we're going to kind of look at right now. I'm going to use this as an example, and I'm going to walk us through the problem of how we can use areas that we've been talking about. You'll notice you see a lot of rectangles and circles, which are two of the shapes that we've been discussing for area, and how we can use that to determine the areas that would need to be painted, and then how much paint we would need. So here's my recreation of that basketball court without the obvious shaded in colors, but I do have it labeled B for the blue areas, R for the red areas, and I didn't have a yellow marker that would show up, but I got Y for the yellow areas. So kind of what's important here is to understand the shapes that we're dealing with and how we are going to find the exact areas, knowing that, you know, it's not an entire circle that we have yellow. All right, and not only do we not have an entire circle that's yellow, but we're also removing some pieces. And this is a little different from the composite shapes that we looked at before, where we kind of added things together. This is going to be one where we remove things from the inside, so we're going to be subtracting the areas out of them. First, let's start with the easy parts. It's always a good spot to go. So if I look at the red circles, all right, I've got one full red circle here, and then I've got a half red circle and a half red circle. So really, what we could look at are two whole red circles. And we need to find the area of these, and hopefully in your head you're thinking, oh, well, to find the area of a circle, we're looking at pi r squared. And remember, pi, we're just going to use the decimal approximation, not equals, remember, the decimal approximation of 3.14, and r is the radius of the circle, which goes from the center of the circle to the outside of the circle. Now, I put some dimensions in here. These are actually pretty accurate dimensions for a professional basketball court. And what I have here is that from the bottom of this circle to the top of the circle is 12 feet. And when we look at the formula for a circle, pi r squared, r, remember, goes from the middle to the edge, and this is going the whole entire way. So this is actually the diameter. So the diameter goes all the way across the circle, which is double the radius. So all we have to do here is, if the diameter is 12, that means the radius is going to be 6 feet. And we just have to substitute that information into the formula. So our area is going to equal 3.14 times 6 squared. I got my calculator right here. I know that 6 squared is 36. So I just need to take 36 times 3.14, and I'm going to get 113.04 feet squared. Now you can see it better. So that's going to be the area of one red circle. But remember, we got one red circle and two half circles. So basically we have two red circles going on here. So I just need to double this. So I'm going to put a little note up here. Here we go. So the red area is going to be 226.08 square feet. All right, so that's going to give us the area of the red parts of the court. All right, next is going to be the blue parts of the court, which is going to be much more challenging and in-depth than the red parts. All right, so we're kind of going from easiest to hardest here. So the first thing I have, let's start with the easy part or the difficult part, are the lane parts here. We call this the key in basketball. These are just simple rectangles. So to find the area of the rectangle, it's just length times width. Well, we have 14 feet by 15 feet. So we just have to look at 14 feet times 15 feet. Once again, got my calculator. Let me pull that out. 14 times 15. That's 210 square feet. All right. So one of these is 210 square feet, but I got two of them. So multiply that by 2. I got 420 square feet. All right, so that takes care of this part here and this part here. But what we got to figure out now is this part. All right. So I've got an entire rectangle. I've got a rectangle that's 50 by 94. But the blue part isn't the entire part of that. I kind of have to remove these half circles here from the 3-point lines, and I'm also going to have to remove that circle there. All right. So the way I'm going to start this is I'm going to find the area of the whole entire thing, and then removing those other areas is going to be a subtraction problem. All right. So if we look at the dimensions of the whole entire rectangle, I've got 50 feet by 94 feet. So that area, 50 feet by 94 feet, that gives me 4,700 feet squared. All right, but once again, the whole entire thing isn't blue. All right, so that would be if the whole court was blue. So now I got to remove some parts. All right, so the first thing I'm going to remove is this center red circle. All right, so that center red circle, I don't know if you remember, was 113.04. All right, so we need to remove the 113.04 square feet, all right, because that's not blue, that's obviously red. So I'm going to do just that. So 4,700 minus the 113.04, that's going to leave me with 4,586.96 square feet. All right. So I removed that part, but now I've got to remove this whole 3-point area. All right. And the 3-point line in basketball, the 3-point line is going to be the same distance from the basket in all directions, which we talked about before. That's actually the definition of a circle. A circle is every point that's the same distance. So this 3-point line combined with this 3-point line would actually make one whole circle. So what we would have to do is find the radius of this. If we found the area of that circle, we would be removing the 3-point lines. All right. And looking at the diagram, what I have right here, 22 feet, is basically going from the center of the circle out to the top of the 3-point line. So that radius is going to be 22. So let's find the area of that circle. All right. So for the 3-point areas, I'm going to look at pi r squared. We did this earlier. So pi times 22 squared, which is right there, ironically. All right, so 22 squared times 3.14, that's 1,519.76 feet squared. So that means I need to remove that big area from this. So I'm going to subtract 1,519.76 from what we had before. 586. So now we're down to 3,067.2 square feet. All right, so let's figure out what we have right now. All right, so I'm going to kind of go through what we just did. All right, so on a smaller scaled version, the first thing I did was I found the area of this whole rectangle. All right, so 50 feet by 94 feet was this. Then I removed the little circle. So I got rid of that part. Then I removed the 3-point areas. All right, so I got rid of that part, got rid of that part. So what I have right now, this 3,067.2 square feet, is dealing with all of this area right in here. All right, which is almost all of the blue. All right, but what we have to do now, if you remember from the very beginning, we talked about these blue areas. All right, so those blue areas combined were 420 square feet. So the last step to find the area of all the blue is just add that 420 to the 3,067 that we have, and that gives us 3,487.2 square feet. All right, so we have the red area. Now I'm going to add the blue area. Blue is 3,487.2 square feet. And I just realized I forgot the 0.2 down here. All right, so we've got red, we've got blue. Next step is finding this yellow. All right, and once again, we're going from kind of the easiest to the most challenging. So we'll look at now kind of how are we going to figure out this yellow. It's very similar to what we just did. We're going to find the area of kind of this half circle, or really the full circle, and we are going to remove these other parts from it. All right, and honestly, we already have a lot of the measurements that we are going to need for this. We have the whole 3-point area as 1,519.76. We know we're going to have to remove the blue areas from that, so we'll have to remove the 420. All right, and then we're going to have to remove one of the red circles, which is 113.04. So we've actually done all of the work that we need to. We just have to subtract now. So when I say go from easiest to most difficult, this actually turns out to be easy because we've already done the work. All right, so the whole entire 3-point areas, both circles combined, was 1,519.76 square feet. If we remove the blue rectangles, so we're going to subtract 420. And then we'll have to remove the red circle. So we'll remove 113.04. And let me go ahead and get my calculator out here. 1519.76 minus 420. And then minus 113.04. So that's going to leave us with 986.72 square feet. All right. So once again, kind of what I was doing is I had the 3-point line. All right. And imagine I had the other 3-point line. So I had one big circle. All right. That's what this 1,519 was. Then from that big circle, I removed the lane lines. So I took those out. That's what the 420 was from. And then after that, I removed the little red circles. And that left us with all of this area, which, and the painting was yellow, but like I said, I don't have a yellow marker, so I'm just using green for it. and that ended up being 986.72 square feet. All right, so let's clean this up a little bit. So I've got red area as 226.08 square feet. I've got my blue area as 3,487.2 square feet. And I've got my yellow area as 986.72 square feet. I didn't put my units here, partly because I ran out of room for the red one. We'll just put it right underneath there. All right, so I've got all of that. Now what I'm going to do is figure out how much paint do we need. All right, so how much paint is going to be needed to cover all these? I keep looking down because I dropped a cap to my marker. I can't find it. Found it. Okay. So a basic gallon of paint is going to hold, or going to, not hold, going to cover about 400 square feet. That's pretty standard for paint. All right, now we can talk about how many coats we're going to need. So if we need one coat, obviously this is all of the areas we're going to have to cover. If we need 2 coats, just double them. If we need 3 coats, triple them, so on and so forth. All right, so a gallon of paint is going to cover about 400 square feet. So if I'm looking at red, I'm good. All right, 1 gallon of paint is going to cover all of the red portions because this is less than 400. So for red paint, 1 gallon is going to be good enough. All right. For the blue paint, what I need to do is I have to figure out how many gallons. So I'm going to divide this 3,487.2, and I'm going to divide it by 400. 3,487.2 divided by 400. So that's going to give me 8.718 gallons of paint. Now, obviously, we have to round up. Even if this wasn't a 7, like even if this was 8.1, we're not going to round down to 8 because we won't have enough paint. So we always round up in these situations. So blue, I'm going to need 9 gallons of paint. And then yellow, same idea. I'm going to take 986.72 divided by 400. And this is kind of exactly what I was talking about before. Normally, rounding rules say, well, this 4 is less than 5, so we round down to 2. But most people understand the concept. If we only bought 2 gallons of paint, 2 gallons of paint is only going to cover 800 square feet. We're going to be 186.72 square feet short. So that means we always have to round up. So the yellow, we would need to buy 3 gallons of paint. All right. So I know this was kind of a lot, and you might not understand it the first time through. So what you might have to do is go back and rewatch the video, especially for the parts where you might need to find, okay, I use this formula. How do I use this formula? You can go back and pause it and look at the work and go back and listen to what I say about the work. But a quick review, everything that you're going to need is from the 2 formulas, basically. You need to know that the area of a circle is pi r squared, where r is the radius of the circle, pi is just 3.14. Or make sure you follow order of operations and square the radius first, and then multiply it by pi. And then you also need to know area of a rectangle, which is the most basic formula that you learned way back in elementary school when you're talking about multiplication and talking about shapes. Area of a rectangle is length times width. All right. And then after that, it's really just adding and subtracting. All right. If I have a rectangle and I need to find the area of it minus this circle, I'd find the area of the rectangle, find the area of the circle, and subtract it. All right. If I happen to have, let me do it this way. So say I'm looking at a basketball court where I had the area of the key, all right, and the area, the half circle above. Maybe I would find the area of this rectangle and the area of this half circle and add them together if they happen to all be the same color. All right, so maybe all of this was painted blue. All right, so you have to basically just identify what formula you have to use for area. Do I have to add them together, or do I have to subtract them to figure out the areas that we need? All right, and then at the very end, to find the amount of paint, just divide. Divide by how much a gallon holds. So at this point, there is an assignment in the Google Classroom now that you should work on. You might not have a chance to finish it by today, so you can work on it a little bit tomorrow, and I'm not sure if I'll be back in school tomorrow or not. It depends on the whole quarantine situation with my daughters. And if my wife is able to take off, we might switch back and forth. Who knows? If I see you tomorrow, I can give you a hand. If not, I'll put out another video with the next thing that we're going to be talking about. Good luck.